Namaskar. Welcome to the second part of Motor Driver IC MAX22211. So we will be seeing a stepper motor driver. Now we have completed our pin descriptions. Okay. So let's proceed to functional block diagram. So we'll be quickly passing this out. What is there is here. We have VDD pin. You can see 1.8 volt regulator. We have sleep pin which is coming from microcontroller. Okay. There is a fault indication. Either you can drive some LEDs or something through that. So if it is low, then it will be fault. If it is high, then it will be not a fault, right? These are charge pumps, capacitor, flying capacitor. This is charge pump voltage, and this is my motor voltage input. Okay. So here we will be giving around 15 volt or something like that. These are ref A, that is that current setting resistor. This is your enable one. So output one will be like coming up by giving this high. Okay. Then this is D in pin. So here you will be giving PWM1 and PWM2. Okay. And it can decide the direction as well. Okay. So coming to the fact that CDRA, drive regulation, how much current is coming, that it can drive. So you can put a pull down resistor to get that output. iSense A, how much current is going through the output of the motor driver, that also it can be done. So its maximum voltage is 0 to 1.1 volt. So you have to make sure how much resistance you are going to give, and it should be within this voltage range. Similar to this, I mean part A, this is part A and this is part B. So similar to this, part B is also there. Okay. You can see a decay mode setting, whether it is fast mode or slow mode or mixed mode. So that will be set by putting 0 or 1 or 1 or 0, whatever is each case, 1 1 or 0 0. So whichever case we will put, that will be done. So we will be putting actually 1 0, it will be mixed, that is 60% fast and 40% slow. That is decay 2 will be 1 and decay 1 will be 0. Similar to that, you can see for part B as well, like we have ref B, enable B, and inputs of PWM inputs, and then current drive regulation and iSense, and this is my output. So this output pair 1 and output pair 2 will be driving the stepper motor. So this is what the block diagram all about. All right. Now let us proceed to next phase, detailed design description. So if you are really want to design your stepper motor driver very good, you have to read line by line. So you can see R on, I had told you already, the typical it is 0.125 for each half bridge. Okay. So total it is 250 milli ohms. So 2.25 ohm is there. Got it? That is high side plus low side. Understood? So all these things are there. I will not go through each one of them because we have already seen in the pin description what is their functionalities. All right. And the current capacity is 2 ampere RMS that we will be putting up. And we have overcurrent protection, thermal shutdown, under voltage lockout. We have open drain, active low fault pin. Okay. So all those things we will see. And my design is using TSSOP 28. The same, if you want to save space, you can utilize TQFN package as well. So we have sleep mode. So what is the first thing that you have to do is you have to go to sleep pin and try to put it. So what I'll do is I'll just directly open the schematic design, and in that you will see what is the things that is given here. We'll be putting one by one there. Okay. So let's come here. I'll better come to this mode. So let us say sleep mode, right? So you can see sleep mode is there here. So it is pulled down. Okay. So if you pull down, yeah. So if you pull it down, then it will be disabled, right? So whenever you have to run this particular driver IC, then what you have to make sure is you have to make sleep high. So once sleep goes high, then it will start working. Got it? So sleep is fine. Coming to the fact next, PWM controls. So we have like two pins like D in 1A and D in 2A, similarly D in 1B and D in 2B, and this is enable A, enable B. So our aim is first we have to make sure enable goes high. So enable will be going high by a microcontroller pin, and D in will be setting up the input. So what way you want? I will be putting forward direction, that is output 2 to output 1, that is output 2A to output 1A, or output 2B to output 1B. Okay, so like that. So my aim is to put it D in 1 0 and D in 2 1. Okay, so let's come to this. My D in pin, you can see D in 1B, D in 2B is PWM here, and D in 1A and D in 2A is here. So whenever you will put it low and this will put high, then it will go. D in 1 I have to put low and D in 2 I have to put high. So PWM you have to give here, it will be off. It will be giving here, you will be keeping it off. So there is one, constant drive is also there. So I have put D in 1 underscore D in 1 I underscore PWM and 2 PWM and 1B and 2B. So you can see this is not used. It means it is not pulled high, means it is off, and it is pulled high means it is on. Okay, so continuous also you can drive without PWM. So I'll suggest you put PWM here and go on. But before making it like a PWM input, you have to switch this on. So enable A and enable B must be high. Got it? Next, if we see PWM control is done, our current sense output resistor. Okay, so current sense monitor, what will happen? What is the current through A and B bridges, that will be done by isense A and isense B. Okay, so this will be taking through a ADC to the microcontroller. All right, so you can see isense A is here and isense B is, sorry, this is isense B, it should be isense B, and there is isense A here. Okay, so as you can see, isense A I have put it a resistor of 3 kilo ohm, and isense B I have put a resistor of 3 kilo ohm, and similarly this isense A and isense B will be taken to the MCU ADC pin. Okay, by before giving it to ADC pin, you have to go for a buffer circuit. Okay, so let's say this is your isense and this will be a buffer, and then you put it to ADC pin. Got it? That I will be showing you in our microcontroller section. These are all assignment of the pin in here. Next, before going to this, our aim is to put reference A and reference B, resistor as well as these values of isense resistors. So let's design that. So what we will do is we will design that particular circuit. Okay, so as you can see, we have a isense which is I out by K ISN. Okay, so since I am going to use, let us say, low means 100%. Okay, then what will happen? Will isense value will be 75%, 7500. Suppose I out is 2 ampere, then isense is coming up as 0.000267. Okay, now let us assume that isense is 3 kilo, R isense is 3 kilo ohm, then V sense is coming up as 0.8 volt, so which is less than 1.1 volt, which was limit for isense pin, right? Similarly, if you want to calculate that, then let's say ADC scale is your 1 volt or something, or even less than that, then R sense is coming up as 3.75 kilo ohm. So you have, it has to be maximum 3.75 kilo ohm or less than that. So Imax, based on that, it will be decided. So Imax is my I out. Okay. So if you want to keep 1 ampere, then my V sense will be only 0.4. Suppose it is coming 0.5 ampere, then V-sense you will see 0.2 volt. So if 0.2 volt is being measured by the microcontroller, then you can understand that the output current through the motor driver is, or the half bridge is, 0.5 ampere just. If voltage is coming as 0.4, then it is 1 ampere. If it is 1.5 ampere, then the voltage would have been observed is 0.6 volt. So this is how it will be measured. Got it? Now, if you want to use that reduced scale, then reduced scale you have to utilize this, means C4. So if you go for C4, then Isense will be changed from C3 to C4, and this will be like reading Vsense as how much, 1.117 volt. This is wrong. Okay, so our aim must be reduced, so it will be maximum, let's say 1.1 ampere it is, then 0.85. So this is how the design will go ahead. Understood? Now let's go to the next section of the design. We have designed our Isense and Rsense. Got it? If you do have any question here, you can still ask any doubts. And this is the working of like fast mode and slow mode. Now coming to the fact that current drive regulation, okay, CDR. So CDR pin we have already seen like how it was working. So if you come to the circuit, so come to CDR1A and CDR-B. So CDR is where? Here. CDR-B is output here, and CDR-A will be output here. Got it? So as you can see in CDR pins, what I have done is I have taken CDR to a resistor. Okay, I'll just show you here. See, CDR has been pulled up by a 1 kilo ohm resistor. Okay, so whatever the current drive regulation is there, this pin also can be taken to microcontroller pin, and it will like be measured how much is the regulation, right? Next is coming to the fact of setting the current regulation threshold. So I trip. If you want to put a threshold on that, then that's what the reference resistor I was talking about, RFA and RFB was. Okay. So RFA and RFB will be set based on this trip value of resistances. So it will be done by KIFS divided by REF into HFS 100%. So this value is calculated and comes around like 9.5 kilo ohm to 72 kilo ohm. So what I have done is I have kept around 18 kilo ohm. So this is the reason I have kept around 18 kilo ohm. If you want, you can keep a little bit higher as well. Okay. So if you start increasing the RF value, like reference value of this resistance, then what will happen? My I trip value will reduce. It means the allowed trip current will be reducing. So if you want to keep it higher current limit, then you have to keep the RRF lower value. Okay. So if you still go ahead, let's say like 51.1 kilo ohm, then your I trip value will be still reduced. So if you want, you can calculate once what would be the I trip value for RREF 51.1 kilo ohm, and that will come up as how much? KIFS will be 36 divided by 51 into this will be HFS, that is percentage, which is 100% or 50%. Got it? So let me just quickly do that. What we'll do? So this is my formula here, and our aim is KIFS, that is 36 kilo ohm, and my HFS that will put in percentage. Okay, and my I trip will put it as, let's say we want to set it down at 1.9 ampere. Okay, what would be my RREF? So that will come up as KIF divided by I trip and multiplied by HFS. Okay, so it is coming up as 18.94. Okay, now if you try to do, so it was percentage, so you have to keep it divided by 100, so that will come up as 1. 1 means 100% or 0.5 means 50%, so it is coming up as around 18.94. so that's the reason I have kept 18.9. suppose I want to increase to 3.8, then it will go to 9.47. so as you are reducing the value of RREF, your I trip value is increasing. Okay, so if you keep it 51.1 kilo ohm, then sorry, if you keep I trip value as less as possible 1 ampere, then it will be 36 kilo ohm. Okay, if you keep 0.5 ampere max, then it will come up as 72 milliamp 72 kilo ohm. Okay, so this is how your reference value is also designed. Got it? Next, what is the next level of design? So this is how you design all the parameters. Now coming to the HFS value. So what I have kept is HFS 0. If you keep, then it will be maximum 3.8 ampere of limit, and 1 means 50% of limit. So what I have done is, I have done a very good thing here. Come to the HFS pin first. So my HFS pin is here. Okay. So what I have done is, I have pulled it down. Okay. So it means it will be in 0. It means it is limit is 50%. Got it? Now whenever you want it to go, like right now it is 1.9 ampere output each pairs, right? Now suppose you want to make it little bit higher, then you can control through your microcontroller pin and make it high to go to maximum limit. Got it? So this is how it will be designed. Next is coming to the CDR pin, open drain pin we have already seen. Okay. Next is our decay mode truth table. So decay mode decay 2 and decay 1. So what I am going to check in this is, this decay 2 and decay 1 will be set by microcontroller's pin. So that will be 0 0 means slow mode, 0 1 means mixed mode, that is 30% fast and 70% slow, and 1 0 means 60% fast and 40% slow, and 1 1 means fast mode. So what I will do is, I will keep in this mode, mixed mode, which is 60% fast and 40% slow. So as you can see, when decay 2 is high, then it is faster. Okay, you can see 0 0 means slow, and 0 1 means still it is slow because slow is leading. Okay, and both are 1 means fast. Got it? So if you come to the circuit, what is here, dk1 and dk2 both are input pins from the microcontroller, and microcontroller is making sure to set the decay mode. Okay, so once you see here, it is coming up. So my aim is to keep dk2 as 1 and dk1 as 0. So if I keep it 1 and 0, it will be done. Now instead of, like depending on the microcontroller, I have given you one provision here. dk1 and dk2, what you can do is, you can try to add one resistor. Let us say this is your dk2, and put is vdd, and this is your dk1, and pull up to vdd. So let's say this is like 3k, and this is also 3k. So what will happen, what I will do is, I will put it ground as well here. Okay, and this also as ground. Now this is, let's say, 3 kilo ohm, and this is also, let's say, 3 kilo ohm. Now what is our aim? Our aim is to make it dk2 as 1 and dk1 as 0. So I'll put this as not used, so dk1 will be pulled down. Okay, so it will become 0, and I'll make this as used and this as not used. Okay, so if my lower resistor is not used, like it is not mounted, then dk2 will be pulled high. Got it? So hope you have the good understanding. If it is not found out yet, then I'll make it here proper. So this is my dk2. Let me write completely. And this is my dk1. Are you getting it? This is my vdd, this is my vdd. Let's say 3.3k or something like that, anything you can keep, or 4.7k also will be fine value. Now our aim is to make dk2 as 1 and dk1 as 0. Then what will happen? If you want to make that thing, then what you have to do is dk2 you have to make it used and this one you have to make it not used. Okay, means do not mount it, and this one you have to remove it and this one you have to use, so it will become pull down, so it will be 0. So this is what I have done in hardware wise. So even if you like use these resistors and try to use microcontroller also can do this job, right? That's it. So with this almost we have found out everything fine. Now come to the fault protection, how you can determine your fault, like whether it is like OCP, over voltage like protection, or it has reached into any of the like issues that it can find out. Let's say thermals are down or under lock voltage, so anything if it goes, what will happen? Under lockout voltage it will go to low. Okay, so it will drive low. So till the time it is driving high it is fine. So what you can do is come to the circuit, and in this circuit what I have done is this is my fault pin. So fault pin, one V3 V3 is there here and one LED is there. So whenever fault is like low, it means there is a fault in the IC. So what will happen? This guy will glow. It means I will consider that there is a fault that has been identified. Now it will always be high. It means it is not glowing. So not glowing means IC is working really fine. At the same time, what you can do is this particular pin you can take out. Okay. So if you want to take out that, then what will happen? Let's say this is my VDD, and let's say this is my 4.7K, and this is my fault, and this is my MCU pin. So whenever MCU pin will see it high, then what will happen? It will see no issue, no issues. And whenever it will see low, it means high means no issue, and low means issue is there in the IC. Okay, so the driver IC will show low, it means microcontroller will understand that there is an issue with the driver. Okay, and you pull it high definitely, because fault pin is actually open drain pin, open drain. So open drain means it will not be able to give you high unless you give it a pull up here. Got it? So almost we have come to an end of our discussion, and this is what the complete circuit design was there for this particular stepper motor driver IC. Got it? So in our next tutorial what we will do is all these pins that has been like assigned here, that I will map to the corresponding microcontroller that we have studied, and this is how our complete project will be designed. So thank you so much. If you do have any kind of like questions or any comments that you want to give, you please put down your questions in the comment box and I shall be able to sort that out. Thank you guys.